all the submissions. Yes, so now the recording started. I'm personally very excited to see all the submissions that we'll have, and I have a feeling that some of them might turn out being real Syntropy products and widely used use cases. So now let me kick off officially with our keynote guest, Joe Weinman, former executive at Hewlett-Packard, Bell Labs, AT&T, and a member of the Syntropy advisory board. So the screen is yours, Joe.
Hi, I'm Joe Weinman, an advisor with Syntropy Networks. It's an honor and a pleasure to be here with you today to kick off the DeWeb Hackathon, which promises to be very exciting, especially for the lucky and talented winners of the contest. So a little bit about me. I was at Bell Labs, AT&T, HP, a company called Telex, which is in the interconnection business that got bought by Digital Realty. And I've also written a number of books, done a lot of keynotes, written a lot of magazine articles too, that are really all at the intersection of business and technology. And so one thing that has always interested me is the nature of innovation, because I've been immersed in it, but I don't know that any of us truly understands it. And so one attempt to explain the nature of innovation was a very famous book, The Innovator's Dilemma. And in it, Clayton Christensen argues, based on his research, that there are two main kinds of disruption. One is called low-end disruption, the other is called new market disruption. In the case of low-end disruption, the idea is that the incumbent players in a market tend to overserve their customers. They keep adding features in an attempt to beat their competitors, but they just keep adding features that customers don't need, don't want, and probably aren't willing to pay for. And so what happens is that leaves an opening for a disruptor, and that disruptive innovator basically comes in at the low end of the market, serving a niche that doesn't have particularly demanding needs with a lower cost offer. And then what happens is they gradually encroach on the incumbent's territory. Now, it's a very popular theory. There's a lot of truth to it. I'm not sure that it is exactly on the mark because it has difficulty, in my view, explaining innovations that just come out that are better than what came before. So there are things that can be better and yet lower cost. They don't need to attack the low end of the market. They can basically come in with just a great innovation. And the problem with the theory of disruptive innovation is that even Clayton Christensen argues that some of the things that we think of as being the most disruptive, like the iPhone and like Netflix, are not disruptive by their definition of disruption. And so it's hard to picture something that is more disruptive than the original iPhone, which essentially caused Nokia and BlackBerry to exit the market, or than Netflix, which basically drove Blockbuster into bankruptcy and liquidation. And so what is probably more useful is another definition of disruption, or maybe some of the characteristics that match not quote unquote official disruption, but what you and I tend to think of as disruption. And we know it when we see it. We see long-standing incumbents going out of business, or being sold at a fraction of their value just mere years earlier. We see the wealth in terms of market capitalization and in terms of the profit pool going to an innovator. We see some complex situations with things like regulation. Like, what are the regulations for a ride-sharing service that has disrupted some of the traditional businesses? So is it that their workers are employees, or are they contractors? Should they have to adhere to the same safety regulations and so forth? So when something is truly disruptive, the existing regulatory regime doesn't necessarily know exactly what to do with it. So without going into every single one of these items, the point is that we know disruption when we see it. And I think that Syntropy is a great example of a potentially disruptive technology that really offers something better that is also very clever. But knowing sort of just the market impact of disruption doesn't necessarily help us address it or know it when we see it in terms of reproducible process or phenomenon. And so some of the things that we may want to address are things that I covered in my book, Digital Disciplines. And I'm just going to cover the idea of 4 generic strategies and explain what is changing as the latest wave of digital innovation and digital disruption hits. So one of the first generic strategies is something that I call information excellence. And the idea is being able to use information to help improve processes or resource utilization. And actually, Syntropy is a great example of that particular strategy because it uses information, for example, things like latency measurements between nodes to be able to determine optimal routes, thus relieving congestion and improving performance end to end. And so that's a great example of exploiting information to improve a process. In this case, it's a digital process, but it doesn't matter whether it's a physical process like cars on the highway being improved in terms of traffic flow by a ride sharing or navigation app, or whether it's something like Syntropy that is improving the routing and performance of the digital superhighway by using information in that way. A second attribute or generic strategy that can be used to exploit digital technologies in business is something that I call solution leadership. And the idea there is that standalone products become increasingly smart, digital, and connected. And so that includes things like connected autonomous vehicles, but also intelligent thermostats and fire alarms and connected soccer balls and things like that. And the interesting thing about that is once they're digital and connected, then that means that they can tie into ecosystems and become platforms for future feature extension. So Syntropy is also a great example of that because basically you all have the ability to build on top of the core functionality that exists through the API and through assorted tools that you have at your disposal. A third major strategy is the idea of what I call collective intimacy. And this represents the evolution of customer intimacy. And customer intimacy basically entails understanding your customer, understanding their needs, and then being able to tailor custom solutions or semi-custom solutions to that customer based on those needs. And that's everything from the Netflix recommendation engine to, say, an Amazon or Alibaba doing upsell, cross-sell, or even patient-specific therapies in healthcare. So the idea there is that we use a lot of big data with content filtering and collaborative filtering to then basically provide a better solution to each customer or user individually. And again, Syntropy has aspects of that because if we think of each user as a customer, the idea is that data that arises from all users on latency and packet loss and congestion and jitter and things like that helps create a better solution for each user. The last strategy is what I call accelerated innovation. And accelerated innovation is really something extremely useful and interesting, and even innovation can and has been innovated over the past centuries. And so to talk about that a little bit, innovation has 3 major facets to it. And I don't want to call them phases because the last facet can occur before the first one. A good example of that is where adoption of something like torn jeans or faded jeans is then commercialized by an entity. But in general, there are three major elements. There's the invention element or facet, which really has to do with what the Patent and Trademark Office calls novelty. In other words, is this something new that no one has ever thought of before? The second major element of successful commercial innovation is the idea not just that there's a great idea that's sitting in a patent, but that it actually gets commercialized. So there is successful execution of a business model. The business model is a viable one, and it's able to be delivered at scale. And then the third major element is adoption, because even with a great business model, if customers just don't want to use it, then there's no hope for that innovation. And a good example there is Thomas Alva Edison and the invention of direct current. And he went to great efforts to completely design an entire system of generators and things like that, and a distribution system and electric light bulbs. But ultimately, people didn't adopt it because there was a greater value proposition in alternating current. And so even though he fought tooth and nail, it was alternating current that is the system that we use today for at least electric utilities. So there are many different ways to pursue this process. There are, there's a number that I will go into, but the basic idea is that we've seen an evolution from the traditional means of innovation that existed both a long time ago and even up until recently, and some of the new things that the internet and digital platforms and crowds and technique called open innovation are enabling. So I'd like to cover that evolution relatively quickly. But this evolution really has resulted in many different strategies that companies can use to innovate. And a hackathon is one of them, of course. So just briefly, we started with sort of the solitary inventor, and you can think about somebody just sitting on a rock thousands of years ago, coming up with the idea of something round that might make it easier to move things around, and thus was the wheel born. But of course, even 100 years or so ago, or a little bit more than that, there was something called shop invention, where you had a combined lab and sort of small-scale manufacturing facility. That is where the light bulb was invented and perfected, at least the carbon filament light bulb. And then that gave rise to the great corporate research labs like Bell Labs and like GE Research Labs and Xerox PARC and IBM Thomas J. Watson. The companies realized that doing everything within their own company could be a mistake. It was great in terms of maintaining proprietary control of knowledge, perhaps, but there were many more people outside of the company than existed inside the company. And for that reason, there was something called open innovation that was invented or discovered. And the idea there is that companies can take ideas that come from outside the organization and bring them into their funnel, or they can take ideas from inside the organization that maybe that company doesn't have the skill or resources to be able to commercialize, and give it to somebody else to partner with. And so if you think about the recent Pfizer-BioNTech partnership, that's a great example. BioNTech was unable to commercialize a vaccine by itself, and Pfizer was unable to develop mRNA technology by itself. But working together as partners, they were able to bring something to fruition over a period of a year or several years that they have been working together. So that is a great example of open innovation based on sort of existing either academic or industry partnerships. Now, another example, though, which is very recent, is the idea of crowdsourcing in general. So being able to take inputs, not just from within the company, not just from a set of existing partners, but opening it up to anyone that wants to participate. And to do that, of course, the internet and big data come in extremely helpful, because what companies do is when they have a problem or a opportunity area that they'd like to pursue, what they then may do is publish anonymized big data sets on the web and open the contest up to anyone who wants to participate. And so those solvers then basically provide solutions back into the system, and either through quantitative or qualitative criteria, they then determine who the winner is or winners. And from that, there's awards that are given or what have you. But certainly the DeWeb Hackathon is an example of using this type of strategy. And so, there's lots of different variations. You have things like innovation networks, which is more standing partnerships. And Pringles famously used one of those to be able to find a baker in Italy that had already perfected a machine to be able to print text or images on baked goods. And so they use that for their potato product. So that saved them a lot of trouble, obviously. Another good example is idea markets. And here, this often is extremely technical challenges that are then solved by extremely technical solvers. And it may involve things like lubricants that don't freeze between -30 and -10 that are non-toxic, and moreover are suitable for a life of 10 years or what have you. And so again, here what happens is the solvers and the challenge can be matched up through an intermediary platform. What I really like is contests and challenges where basically there's a prize. It's awarded to the top one or several solvers. Good examples of that are the Netflix prize. That was $1 million prize to improve their recommendation engine. GE has done a number of these. They did 2 in the area of aviation. One had the objective of improving flight arrival time prediction accuracy, and the other one actually had the idea of trying to reduce time in the air. And for these challenges, there are very sophisticated techniques that are used, and the data sets include things like takeoff and arrival times, and particulate matter at various voxels within the atmosphere. So it's really just incredible the amount of talent that gets applied to challenges like that, or like this DeWeb Hackathon. And then finally, what we're seeing is some interesting things in terms of solvers who don't necessarily need to be technologically sophisticated, even in the industry or scientific area that they're solving in. And a good example of that is Foldit, which was intended to find the protein folding structure of a particular molecule. And it had eluded the best scientists and researchers in the world for 15 years. And then what happened is they put it on the web, and within 3 weeks, okay, so basically 3 weeks versus a decade and a half, someone that knew nothing about biochemistry, but was able to visualize how things might work, solve the problem of protein folding. And of course, we're even moving into an era now of machine innovation. A good example of that is the Google DeepMind AlphaGo algorithm/system, which beat the world's top human player. And it did that both by studying human games and also playing itself hundreds of thousands of times. And the really interesting thing to me about that is not that a machine can learn to play Go, although that was a major achievement. But in game 2, what happened is the algorithm made a move, and all of the human observers were stunned because they thought, this is like a horrible move. It's obviously a bug in the software. And it only became clear dozens of moves later that the machine had come up with an entirely new tactic that humans had never encountered or developed before. And so we have machines that can play Go. There are machines that can do many things. One of the most exciting ones is the idea of Melvin, which is a machine that designs quantum physics experiments, which is pretty amazing. And so what we see is that there are a number of different things that are happening and innovation is being innovated. I'm delighted that you all here today are part of this new type of innovation in a area that has both solution leadership and information excellence and collective intimacy. So it's a great case study and something that really will enable the programmable internet and the democratization of the internet. And on top of that, I just think it's really cool how it brings together blockchain and security and advanced routing. And so I wish you all good luck. Here's my contact information if any of you want to stay in touch. And otherwise, I hope you have a great hackathon. Thank you so much for letting me help kick this off.
Thank you, Joe, for this presentation. It's amazing to have experts of such level on the Syntropy advisory board. And I can assure you that our community loves it. And now Syntropy CTO Jonas will give more details on our tech and will introduce the challenges you are going to solve during DeWeb Hackathon. So Jonas, you can go.
Hi everyone, and thanks for participating in the hackathon. I just wanted to thank again for the getting together, and the whole team is very proud to share our technology with the world and help you build the solutions of the future. And we're even more excited to hear about all the new ideas and the new contributions created by the wider developer community. So let me very quickly introduce the challenges where Syntropy technology can be applied, and hopefully that will get you more excited about the hackathon. Maybe we'll give some ideas. So there are some main challenge categories which were identified, and one of them, and the first one, is a blockchain. Blockchain is a very exciting category because there's exciting stuff to be built. For example, node infrastructure or staking services using our technology, or some interoperability solutions to connect several blockchains together, or a staking as a service application, or anything in between. Another track of challenges, and that's my favorite, is the gaming. So there's so much which can be built using Syntropy technology. For example, an application for esports to help them organize tournaments and play safely in a private and optimized network. There's also integrations for any game possible where people play on servers or help them play together in a server using a secure network. Then there's IoT apps. IoT is a very, very wide topic, and there's so much creativity to do interesting stuff. For example, Raspberry Pis, smart home solutions, port Syntropy to some hardware which we haven't seen it running on, and this way, you know, there's unlimited possibilities to connect things across internet. Another stream is software apps. So, you know, very simply, build next generation VPNs. If someone wants to build a newer, better, faster, better looking VPN, now you can use Syntropy technology behind the scenes and avoid creating the network layer. But you know, you can still use Syntropy to create the future VPNs, or an easy way to build your own VPN. And finally, there are tracks like DARP data analysis. So we're very proud that we have been collecting data for a while of various different latencies around the internet. So maybe for those data scientists or for backgrounds which are interested in data science, there's also an opportunity to analyze the data, show it in a more beautiful way, show the world how internet can become better. And that is also, you know, similar to the UI UX track, where we welcome any improvements which can be made on the visuals, on the appearance, or the usability of our technology. So these are just a couple examples of what can be built. And we really wanted to kind of leave it open for you to create those ideas, ask us, ask for feedback, ask for help, get together, and then let's build some new stuff. And hopefully that'll be an interesting experience. Hopefully you'll learn a lot about internet, about Syntropy, about blockchain in general. And without further ado, I declare this hackathon open.
Thanks, Jonas. I'm really excited to begin this adventure. Before we do that, let me share some general hackathon information with you. So first of all announcements will be made on our Discord channel. So make sure you have joined our community here. You'll find the link in Hackathon newsletters we sent earlier. I'm sure some of you haven't found your team members, so you can do that on Airtable or post in Hackathon team information Discord server. We also contacted every one of you individually offering our assistance, so please check your Discords or emails for that. The deadline to submit your project is on 21st of June. Make sure that your submission meets all the requirements. Those requirements will be communicated tomorrow. Your projects will be evaluated by a set of criteria, which is relevance, impact, creativity, innovation, quality of code, and presentation. The winners will be announced on the 28th of June, and we will contact the winners by email. So we'll keep you updated on our Discord channel. If you have any questions, share them on Discord or drop us a line at hackathon@syntropynet.com. Also, you can always join our Telegram group where our community managers will help you as well. So thank you, and let the hackathon begin. Bye.